All right, so let's wrap up this last part of the lesson for lesson 2. And I want us to talk about the two different types of limits that we are discussing in this section that involve infinity. So to do that, let me make it easy and write it right here so we can talk and you can look at the same time. Oops, need to get my nice bright dark colors here again. So we have limits where we take x and approach infinity, or we could approach negative infinity, either one. And we also have limits where we're approaching just some number, so we'll call it a, and the answer that we get, so I don't know what the function is, I'm going to leave that blank, but the answer turns out to be either infinity or negative infinity. So those are the two types of functions, and actually here I should say we have limits where they're going towards infinity, and every now and then they actually equal a value. So let me find, I want to do, let's see, make this, we'll call this the limit for f, and we'll call this the limit for g, just so that we can have a function there. Okay, so limits where we're approaching either positive or negative infinity, and we get a numeric answer. What does that mean on a graph? Well, technically, we can use all this kind of calculus type language, but what we're finding is a horizontal asymptote. So if we take a graph and we ask ourselves, what's happening to this graph as it goes out in either direction, positive infinity, negative infinity, what's happening to this graph? The answer that we get, if it's a number, we've discovered the horizontal asymptote. So if I say the limit of sine of x over x, remember we talked about that multiple times, sine of x over x, what happens as the graph goes towards positive and negative infinity? Well, it approaches 0. What does that mean? It means that the horizontal asymptote is y equals 0. It's the line y equals 0. That's the horizontal asymptote, which we already knew. We observed that in the graph, but we want to make it kind of clear in our own minds that the limit is actually defining that asymptote for us with some mathematical language, symbolic language. On the other hand, we have limits that we're finding x as it approaches a number, a specific number, x approaching a, so it could be approaching 1, it could be approaching 0, it could be approaching 10, it doesn't matter, where the answer turns out to be negative or positive infinity. Well, the example that we saw in the last section of that was the graph of 1 over x squared, or 1 over x. 1 over x squared, we were approaching 0, and the graph went up like this to positive infinity. What did we find there? Well, we found a vertical asymptote. The graph is approaching positive infinity at that value, and so right here we have a vertical asymptote at x equals 0, because we were approaching 0, we were approaching x equals 0, and we went to infinity. So what did we find? We found the vertical asymptote of x equals 0. And actually, maybe I should write that out here. So on our sine of x over x example, we found a horizontal asymptote, which was y equals 0. And for our 1 over x or 1 over x squared example, we found a vertical asymptote at x equals 0. And that's also the same for 1 over x, because 1 over x looks like this, all right? And so as we approach 0, it was approaching negative infinity from the left side, positive infinity from the right side, but what did we find? We found the vertical asymptote right there at x equals 0. So if we're approaching infinity or negative infinity and we get a number, it's a horizontal asymptote. If we are approaching a number and get infinity as the answer, we just found a vertical asymptote. So if you want to note that in your own notes, you should probably write down that this is a horizontal asymptote and this is a vertical asymptote. One other thing is what happens if we're dealing with infinity and neither one of these situations happens. And let me give you an example of that, actually. We'll say, here's my example. So we have, let's take f of x and let it be 2x to the 5th plus x to the 4th minus x squared plus 1 over, so this is a rational function, 3x squared minus 5x plus 7. There we go. Okay, and let's find the limit with a different color here. Let's do the limit of this function as x goes towards, let's think about positive and negative infinity and see if it's the same or different. So just like we did in the first video, if we're trying to approach infinity, we can think about it almost like we're plugging infinity in, even though you're not really allowed to do that because it's not a number. But when we think about it that way, we see that we have infinity to the 5th power, infinity to the 4th power, infinity squared, and then just plain old plus 1. And none of this really holds a candle to this leading coefficient. So we say that all of this is essentially unimportant and we really only care about 2x to the 5th. On the bottom, we do the same thing. We really only care about 3x squared because these things are not negative 5 times infinity plus 7. That's moving so much more slowly compared to 3x squared. It's not really going to affect the pattern of what's happening as we move towards infinity. So all we really care about is 2x to the 5th over 3x squared. Now, when we try to find the limit of that, we end up, so we're saying the limit now as x approaches, we're going to talk about both infinities, essentially 2x to the 5th over 3x squared, which can be reduced. That reduces 2 over 3 we can't really reduce. That's just still 2 on the top, 3 in the bottom. We have x to the 5th over x squared. That actually reduces to I'm just going to write it like this. I want to make sure I'm writing it the same way with a little arrow here because I'm not rewriting. I should be rewriting limit if I had more room, but I'm just going to replace it. So this all simplifies to 2/3 x cubed. So what happens is the limit as we go towards infinity, if I were to plug in positive infinity here, we would have 2/3 times infinity times infinity times infinity, which is just, we're growing towards infinity really fast. If I were to plug in negative infinity, I'd actually have 2/3 times negative infinity times negative infinity times negative infinity, which is growing towards negative infinity very quickly. So as we go towards positive infinity, it's getting positive, more and more positive. And as we go towards negative infinity, we're going towards negative infinity in the direction of the graph, in the downward direction. That's what I want to say. So, does this have an asymptote? No, because remember, let's go back to our little, what I've scribbled on our screen here. In order for us to have a horizontal asymptote, right here, we have to get a numeric answer. As we go towards infinity, we have to be getting like 0 or 1 or 5 or something as a numeric answer to say that the graph is leveling out to that number. That's not what we got in this last example. We got essentially either positive or negative infinity. We don't have a horizontal asymptote. So you might ask the question, okay, great, so the answer here would be plus or minus infinity, depending on if you're plugging in plus or minus infinity. Is that important graphically? Well, yes, it is. It's actually something that we call end behavior of a function. And this right here, 2/3 x cubed, is explaining to us what the end behavior, meaning the outer behavior of this function, the one we started with the 2x to the 5th plus x to the 4th, and everything else I scribbled out, that function, as it moves outward, it's going to behave roughly like the graph of 2/3 x cubed, which, if you remember from pre-calc and algebra, x cubed looks like this, right? So the end behavior is going to turn into positive infinity as it moves right and negative infinity as it moves left. And so, no, we didn't find an asymptote, but we did find an accurate model or a simplified model representation of how this function behaves. In this case, it was 2/3 x cubed. So let's clear this here for a moment and recap. we discussed three important things. One is if I use a limit to approach infinity, positive or negative, and I get a numeric answer, I have found a horizontal asymptote. If, on the other hand, I am approaching a numeric value with a limit and I get an answer of infinity, positive or negative, then I found a vertical asymptote. So I was approaching a number and I got infinity, that's a vertical asymptote. Lastly, if I'm moving towards infinity and I don't get a numeric value, instead I get like a function, or which would then give us an answer of infinity, positive or negative, that is not any kind of asymptote, but it does give us what we call end behavior of the graph. It tells us the rough shape of the graph as it moves outward towards positive and negative infinity. So horizontal asymptote, vertical asymptote, end behavior. And that should wrap it up. And that's the end of lesson 2.